AI is not something for the future, it has already come. And if you want to grow as a Java developer, we must learn how to work with AI right now. In this course, I'll show you how to use GitHub Copilot to write code fast, fix bugs in just seconds, create full-stack Java projects without any headache, and even build powerful Spring Boot applications, all with AI working like your personal Copilot in VS Code in our Java projects. We basically need to ensure we have installed 3 different extensions. But before that, do make sure that you have the latest and greatest version of JDK installed on your computer. To verify the same, you can press Ctrl+ and type in the command java-version and make sure that you're seeing the version that you've installed. The first extension we need to make sure we have installed is the extension pack for Java. If you've been working on Java projects, you must have already installed this extension. If not, if you're just getting started with VS Code, go ahead and install this extension. And while installing, you might be asked to choose the Java version. Make sure that you choose the latest version. This is the extension which will give the IntelliSense to VS Code to help us work on Java projects. And it also comes with a bunch of tools like Test Runner, Debugger, etc. to help us work on Java projects. The next extension we need to install is Spring Boot Extension Pack, which is not really mandatory, but we need to install it if we're working on Spring Boot projects. And in fact, in this course, we're actually going to work on Spring projects to demonstrate the power of Copilot. Spring Boot Extension Pack. This is what would enable us to work on Spring Boot projects, and it also comes with a bunch of tools like Spring Initializer, which will help us seamlessly create Spring Boot projects with all the required dependencies. It also comes with Spring Boot Dashboard, which will help us visualize the REST endpoints, show all the running Spring Boot applications, or even start-stop the applications as required. So go ahead and install this as well. Next, guess what? We need to install Copilot extension. I'm going to search just that. Since I've already installed, I'm not seeing the option to install, but please go ahead and install GitHub Copilot. And while installing, you might be asked to log into your GitHub account. If you don't have GitHub account, go to github.com, create your account, and then log in with those credentials. Once you install these extensions, we're all set to start using Copilot in our Java or Spring projects. I'll see you next. Okay, let us see how we can set up Copilot in IntelliJ IDE. But before that, we need to make sure that we have the latest version of JDK installed on our computer, and also make sure that we have the latest version of IntelliJ as well. Once you have them, go to File, Project Structure, and make sure that you choose the right SDK version. The language level is also important because it will set the features the code assistance in the editor should support. So once you have them, we're good to go and set up Copilot. To set up Copilot, go to Settings and click on Plugins. Go to Marketplace and search for GitHub Copilot. It's also really worth mentioning that IntelliJ also has its own AI code assistant. However, it's not as accurate or contextually aware compared to Copilot, because Copilot uses ChatGPT 4 and Codex, which have been trained on vast amount of open source projects available on GitHub. And in general, I find Copilot can better handle complex prompts compared to built-in AI assistant. Copilot can also generate very complex functions and classes, and I find integrated AI assistant not so effective. So choose GitHub Copilot and install it. Once installed, we need to restart our IDE. So let's click Restart IDE. Restart. So we have installed Copilot plugin. Now we should be able to see this Copilot icon at the top left corner as well as the bottom right corner. Click on that icon and click on Login to GitHub. We now need to log into our GitHub account and authorize IntelliJ to access our GitHub account. So click on copy and open. Click on continue. If you don't have GitHub account already, you can just create one and log in. It would ask you to enter the code. You need to enter this authentication code to authorize IntelliJ to access your GitHub account. Once you do that, click continue. Click on authorize GitHub Copilot plugin. And we're all set to use Copilot in our IntelliJ IDE. I'll see you next. Let us see how we can set up Copilot in Eclipse. But before that, do make sure that you have the latest and greatest version of both JDK and Eclipse. Once you have them, go to Help, click on Eclipse Marketplace, and search for Copilot. There's an official Copilot plugin from GitHub, but unfortunately, it lacks some of the features. For example, it doesn't have the chat support, at least by the time of this recording. What we want to do rather is we want to install this plugin named Copilot for Eclipse from GNUtech. So go ahead and install it, and you might need to restart your Eclipse once you install. Once installed, you should be able to see this icon at the bottom right corner. Click on it and click on Sign in to GitHub Copilot. We need to now authorize this plugin to use our GitHub account. So click on copy code and open. If you don't have GitHub account, you can easily create one and then log in. Click on continue. Paste the code that you've just copied and click continue. And then finally authorize the GitHub Copilot plugin. With this, we're all set to use Copilot in our Eclipse environment. I'll see you next. We'll be using IntelliJ IDE for the rest of the course. If you're using different IDE, you should know this. While Copilot works across different IDEs like Visual Studio Code, JetBrains, IntelliJ IDE, Eclipse, etc., there might be slight differences in the features supported, shortcuts used, and the way they function. The core functionality though, like AI-powered suggestions, code completion, and assistance, remain the same across all environments. However, one key difference lies in the shortcuts and key bindings used to interact with Copilot. While some keyboard shortcuts remain the same across different IDEs, some do differ depending on the environment. Each IDE has its own set of key bindings, and if I were to cover all of them, it would add unnecessary repetition to this course. Instead, we'll be focusing on IntelliJ IDE because it is the most popular IDE among Java developers. By concentrating on IntelliJ, we ensure that we go in depth without overwhelming you with redundant information. That being said, don't worry if you're using a different IDE. I've provided a cheat sheet that you can refer to. So whenever I use a particular shortcut in IntelliJ IDE, you can simply look at the cheat sheet to find the equivalent shortcut in your IDE. To get the best learning experience though, I highly recommend installing IntelliJ IDE and following along with me. This way you can get hands-on experience and understand how Copilot works in real time. Once you're comfortable, you can easily connect the dots and apply the same concepts in any other IDE you prefer. So let's dive in and start exploring how Copilot can supercharge your Java development in IntelliJ IDE. I'll see you next. Let's create a Maven project in IntelliJ IDE so that we'll have something to work on and start using Copilot. If you already know how to create a Maven project in IntelliJ IDE, please go ahead and do that. You can skip this lecture and move on with the next one. If you don't, just follow along with me because we're going to do just that. To create a Maven project, go to File, New, click on Project. Choose Maven archetype, give our project a name. I'm going to call it as ByteForge. And then I'm going to choose the archetype as Maven archetype Quick Start. Now, since this course is not about Maven, I'm not really going to delve deep into these details. I will leave rest of the fields to their defaults and click Create. Wait for a bit for the build to finish. Once the build is success, we have the project ready. We can now start using Copilot. I'll see you next. Okay, let's see how we can generate code like classes and methods using Copilot. For that, let's create a new class file. I'm going to name our class as Math Utilities. Now the moment I go inside the class and press enter or return, Copilot suggests me some code. What you're seeing here is called ghost text. It's gray in color and it's Copilot way of asking, do you want this code to be present in this file? If you want to say yes to it, we would press tab to accept the code. I'll press escape and the suggestion is gone. If you want to now ask Copilot to show the suggestion again, we can either go back and press enter, or we can just press Alt / to ask Copilot to generate the code. And sometimes Copilot might have multiple suggestions. If we want to navigate through those suggestions, we can press Alt > to go to the next suggestion, and as you can see, code has slightly changed. Or we can press Alt left > to go to the previous suggestion. If you're not seeing any new code while you press Alt > that means Copilot does not have any suggestions to make. And we don't have to accept the entire code in one go. We can also accept one word at a time or one line at a time. If we want to accept one word at a time, we need to press Ctrl right arrow to accept one word at a time. And if you want to accept one line at a time, we want to add Alt to it. So we press Ctrl Alt right to accept one line at a time. Now you might be wondering how Copilot is able to generate this code. Well, we've named our class as Math Utilities, and Copilot is smart enough to understand what code we might be needing here. And by the way, even if you're creating the exact same class with the exact same name, you might be seeing an entirely different suggestion. Copilot generates the code based on the context awareness it has. Now let me either press enter or press Alt / so that Copilot will continue to make suggestions. And I keep on accepting if they make sense. Sometimes Copilot may not be generating the code that you need, in which case we can ask Copilot to generate the code we need, and one of the ways we can tell it is by using comments. We Java developers often use comments to describe the method. And generally we write the method and then put a comment. But here we can make a comment to ask Copilot to generate the code for us. For example, I'm going to add a comment saying method 2, and by the way, Copilot is trying to make a guess here as well, giving us suggestions on the comment. If you want to accept it, once again you can press tab, or you can just continue typing. So I'm going to say method 2 return an array of prime numbers up to n. And the moment I press enter or return, Copilot is actually going to show the ghost text showing the suggestion. I can just accept it by pressing tab. So it's really important that you write clear comment. The better you describe your intent, the better Copilot's suggestion is. Also, sometimes Copilot generates code with some errors or with some missing code. In this case, it has worked perfectly well, but sometimes it doesn't. It might have some missing code like this, resulting in errors. Again, you can just go to that place and ask Copilot to make a suggestion by pressing Alt / and it's going to fill the code as required. We don't have a return statement here, so I'll go there and press Alt / and accept the suggestion if it makes sense. Another way to ask Copilot to generate code for us is by giving a meaningful name to our methods. For example, I'll say public static, and look, Copilot is already trying to make suggestion here. A method to see if a given number is prime or not. In fact, believe it or not, that's exactly what I'm about to type. You can just actually type in the method name is prime, and we have an error here. That's because this method is not returning anything. Public static boolean. So sometimes you actually have to involve and make changes because Copilot is not perfect. It's not really going to do your job, but only going to make your job easy by making suggestions. It's only going to generate code based on the context, structure, and intent, but you still need to review and refine its suggestions. And that's where our knowledge comes into picture. This is how we generate code using Copilot. This is how we can also generate CRUD repositories or controllers as well. Down the line, we're going to have more robust examples, and we'll take a look at some of the really interesting features that Copilot offers to make our job easy. But as an assignment, I want you to create an employee class with getters and setters, the constructor, and a method to calculate annual salary. Go ahead and do that with the help of Copilot. Let's see how we can create an employee class. I'll create a new class called employee. And here I will make a comment saying a well-designed employee class with constructor, getter and setter methods, and a method to calculate annual salary. Once I press tab, we have the code. So get annual salary is simply multiplying the salary by 12. It has also added an additional method called raise salary, which is good to have. I'll see you next. Inline chart is great for quick code specific answers right inside your editor. You highlight some code, ask a question and get a short response. But what if you need deeper discussions, debugging help or conceptual guidance? Well, that's where chart view comes into picture. To open chart view, you can click on the Copilot icon at the bottom right corner and click on Open GitHub Copilot Chat. Alternatively, you can also use the shortcut Ctrl+Shift+C. The chart view opens in a separate panel, giving you space for structured conversation. And unlike inline chart, which answers simple questions, chart view allows follow-up discussions as well. It's like an evolved version of inline chart, which remembers your interaction with it. So you can ask a follow-up question and get better answers over time. For example, while working on your project, if you come across with any error, you can just paste the entire error log here and ask how to fix it. It would suggest you how and where to fix it in your code. Or if you're exploring a design pattern, or you need performance improvements in your code, or if you want to know deployment strategies, ChartView gives detailed insights, something inline chart just isn't built for. For example, I want to know how to deploy this application in AWS. And it's going to come up with instructions on how we can do that, along with commands we need to run. So we can follow these instructions and deploy the application. And if you have any other question, we can just ask it out and it would come up with a solution. We can also ask how to implement authorization in our application. and it would come up with all the instructions you need to follow to implement authorization in your project. It clearly points out what files we need to create, how to configure them, where to create them, etc. And if we are required to make any changes in existing code, it would suggest the same as well. Well, at this point, it doesn't make sense for us to implement authorization in this particular app, but down the line, we're actually going to create a Spring Boot application from scratch, and there we might actually implement authorization and authentication. But for now, the more sensible thing we can do is to implement logging in our application. So I'm going to ask just that. So it is asking us to add these dependencies, SLF4j as well as logback. And then it is asking us to create this file named logback.xml inside the resources folder. And it has pointed out other configurations we need to make it work. I can also ask a follow-up question, how to use this in my code. So it is showing some suggestions as to how we can implement it. If you notice, it has generated our employee class with logging mechanism. I can just copy this code, or I can just simply paste the code or just replace the code like so. However, we're going to have compile time errors because I don't have that dependency yet. So I'll quickly undo it. One thing that's unique about chat view is that it remembers our conversation. I can go back and see the prompts I had entered and the conversation I had. I can also delete a particular prompt if I find it not relevant for this conversation. Or if I want to start an entirely new conversation without any context, I can click this plus icon to start a new conversation and start asking questions. I can also go back and forth between conversations. So if I view all the conversations, it's going to show up all the sessions we have. I can double click it to go back to the previous conversation. Or I can also delete one of these conversations as well by right clicking and delete conversation. And it would delete the conversation and the context is also cleaned up. Now as an assignment, I want you to implement logging in our application by using Copilot Chat View. Well, it has a bunch of other features as well. We will be exploring all of them in coming lectures. I'll see you next. Ever felt like you need a coding buddy who sits along with you, listens to you, and does the job for you? Well, GitHub Copilot Inline Chat is exactly that. It's a quick way to ask Copilot what you need. To bring him up, we press Ctrl+Shift+G in IntelliJ IDE, or alternatively you can just right click, go to GitHub Copilot and choose Inline Chat. Here I'm going to ask it to generate code for us. In fact, this is more sensible way to ask Copilot to generate the code for us than writing comments or asking it to infer from method names. So I would say add a method to find the sum of even numbers in an array list, and I would hit enter. If you're not happy with the result, no problem. Just hit escape and just ask again. It's like you're arguing with your coding buddy until they finally agree with you. However, I'm happy with this code, so I'm going to insert it by clicking this icon that says insert code block at cursor. You can also copy the code and do it by yourself. And our code is here. You can also ask it to make changes in our code. For example, we're using array here, but maybe I'd like to use array list instead. So I'm going to ask Copilot to do just that. So I would select the code where I want the changes, and whatever you select, Copilot focuses on that part. I would then press Ctrl+Shift+G to get the inline chat, and I'll just say I want to use array list. Let's see what it does. And see, it has generated the code for us and is using array list. Since our code is already selected, I'm going to insert the code at the cursor. That would essentially replace the selected code. And there you have it. We seem to be having errors here. I would press Alt Enter to import array list. We can also ask Copilot to fix errors for us. And I'm not talking about those funny compile time errors. It can fix logical errors as well. For example, we have this method isPrime that finds out if a given number is prime or not. Let me mess up with this code a little bit and see if Copilot is smart enough to fix this. So I would select this code, or I can also select the part of the code. I'll do Ctrl+Shift+G and I'll say fix error. Let's see what it does, and it has identified the issue. I can now select the code that I wanted to replace and click Insert Code Block at cursor. You can also ask Copilot to explain the code for you without being judged or without getting frustrated, like some of your senior members in your team. Let me show you what I mean. So I would select this code, I'll do Ctrl+Shift+G and ask Copilot, explain this code for me and show me how to use it. And it has given all the details you need, including a sample code that demonstrates how to use isPrime method, like so. And you're not just limited to questions on this code. You can ask any general questions as well. For example, I would ask Copilot how to build a project using Maven. And it has given me the command that I need to use. And if you notice, this time we have a new icon that says Insert into Terminal. If I click on it, it's going to open up a terminal inserting that command. All I have to do now is to press Enter or Return to build the project. Alright, we'll continue from next one. Okay, let's take help from Copilot to implement logging in our application. So let me ask Copilot how to implement logging in my application. There's a typo error, but Copilot is smart enough to understand what I want. So first of all, I have to go to pom.xml and introduce these dependencies. So I'll go to pom.xml, place my cursor here, and just push that code like so. We need to remove dependencies tag though, because it's already there. I'll do Ctrl+Alt+L to format the code. Next step, we need to introduce logback.xml under src main resources. We don't have that folder, so let's create one. I'm going to create a directory called main resources, Inside that, we need to create a new file named logback.xml. And we need to copy this content there. But please don't just blindly copy whatever it says. You need to be able to understand what it generates. In this case, it is using console appender. That means all our log messages would be printed on console. And each log message follows this pattern. With date and time, log level, name of the logger with max 36 characters, and then the log message itself. Once you're happy with it, we can move on with the next step, which is to actually implement the logger in our code. So Copilot has regenerated our math utilities class with logging mechanism implemented. So let's go to that class. I'm going to select all the code and replace it with this one. We're going to have errors because even though we have added the dependency, it's not actually there in our local Maven repository. So I'll go to the menu, View, Tool Windows, click on Maven, click on the refresh icon, and click Sync All Maven Projects. Now if I go back, all those errors are gone. We seem to be having some unrelated errors. So let's import ArrayList to resolve them. I'll do Ctrl-Alt-L to properly format the code. And there you have it. We now have the logging mechanism implemented in our project. You can also go ahead and test it out. It should work well. Anyway, down the line we're going to have a lecture on how to generate tests to test our code. In that, we're going to see our log messages getting displayed on console anyway. I'll see you next. Slash commands are shortcuts that help you interact with GitHub Copilot more efficiently. Instead of you typing long queries, you can use these slash commands to get help with coding, debugging, explanations, and even generating entire functions quickly. So I'm currently in the chat view, and if I press slash, you're going to see all the supported slash commands. The explain slash command will explain how the code works. By default, it would try to explain the code inside the current open file. Or you can also select a section of code and run this slash command so that Copilot would explain only that part of the code. I'll hit slash. The feedback command lets you share your thoughts on Copilot's response. So when you use this feedback slash command, it basically shows some instructions on how to share your feedback with the Copilot team so that your feedback might actually help improve the system. You can just simply ignore this for the time being. Also, whenever you get a response from Copilot, you can use the thumbs up and thumbs down icon to share your feedback. If you like its response, you can hit the thumbs up so that it knows that it is actually doing a good job and would continue to do that. If you press thumbs down, it will try to do something to improve the responses. The fix slash command, as the name indicates, it will fix the problems in your code. For example, let's say I have accidentally messed up this code and assume that I don't know what's going wrong here. So I can just select this code and quickly run the slash command fix. And it suggests the code with the fix. I can just simply use it like so. The help command will basically explain you how to use Copilot. This is for beginners. You can just simply ignore this command altogether. The test command would help us generate unit tests, and the doc command will help us create the documentation for our code. We're going to talk about generating unit tests as well as documentation in upcoming lectures, so let's not talk about it now. The simplify slash command helps make your code cleaner and easier to understand. For example, if you have a complex or very lengthy piece of code, you can use the simplify command and Copilot will try to rewrite it in a more concise and readable way while keeping the functionality intact. In this case, our code is already optimized, so it's not really doing much. But let's say that you have nested loops or a long if-else chain. Using simplify can refactor it into more efficient structure. It's basically a quick way to optimize your code without manually rewriting it by yourself. Chat commands are also available in inline chat. So you can just open up the inline chat and press slash to see all the supported commands. Some of the commands are available in chat view but may not be supported in the inline chat. We also have smart actions, which are similar to slash commands, but you do it with mouse click. To access smart actions, you right click, go to GitHub Copilot, and here are they. So go ahead and experiment with slash commands and smart actions. I'll see you next. Let's see how we can generate test cases and also documentation for our code using Copilot. So guess what I'm going to do next? I have the math utilities file open and I'm going to use the slash command tests. My bad, I've accidentally chosen the recommended prompt. By the way, Copilot makes a recommendation on the prompt as well. As you can see, we have a prompt suggestion from Copilot. When we click on it, Copilot will process it. Anyway, let's run the slash command tests. So Copilot has generated the tests. I can now copy this code, go inside the org.example package inside the test directory, and I'll do Ctrl V to paste the code. And we now have the test cases. Of course, we're going to have some compile time errors as we need to import the required libraries. So I will hover my mouse, more actions, and we'll add the Maven dependency. The dependency we need to add is Jupyter API, and we no longer have those errors. If you go to pom.xml file, we now have that dependency added. However, I'm not happy with this code. It is very minimalistic and I want to cover more scenarios. Guess what? I'm going to ask Copilot to do that for me. I'll open the chat view again and I'm going to ask it to add more assertions to test more positive and negative scenarios. Also use BDD or behavior driven development naming convention for the test case names separated by underscore character. Let's see what it's going to do for us. And sure enough, it is now covering positive and negative scenarios as well, and it is following BDD naming convention. I'm happy with the response. So it is also testing if we are getting an exception, covering both positive and negative scenarios as well. And this is exactly what I want. I'm happy with the suggestion. So I'm going to select the entire code and replace it with the one that Copilot generated, like so. Save the file and let's see if our test cases would pass. I will run the command ambient clean install. This would not only build the project but also execute the test cases. And we seem to be having an error, which is a good sign because we want to see if Copilot can actually help us addressing this issue. I know what's going wrong here, but let's see if Copilot can figure it out for us. What I'm going to do is I'm just simply going to copy the error trace and paste it in the chat, hit enter. It has come up with some explanation and it seemed to have figured out the problem as well. We need to make some tweaks in the dependency versions. So instead of we manually comparing the existing pom.xml with the generated code and make fixes, I'm going to ask Copilot to generate the entire pom.xml with all the required fixes. I'm going to select the entire code, replace it with the one that Copilot has generated. Save the file. I'll go to View, Tools window, Maven, and let's quickly reload all Maven projects just to make sure that we have those dependencies. And then let's try to run the command. We got yet another error. It's actually referring to app test file. We don't actually need this file. It was auto-generated. So let's get rid of it altogether. And run the command again. Okay, our build has failed again. But this time, some of the test cases failed. We don't have the problem with the build or the dependencies. This is a code error, and since this course is not about JUnit, I'm not really going to delve deep into this. Actually, we can even ask Copilot to sort out this issue as well. I'll copy this and paste it in the chat. Now do try to understand what it is trying to suggest us. If it makes sense, we can go ahead and fix it. It is basically trying to fix the getPrimes method. So let me go back to math utilities. Of course, this course is not about Java, so I'm not really paying too much attention here. But ideally, in real-time scenarios, you do want to take a look at the generated code and make necessary changes. I'm going to select the code. So I'm going to select this code and place them here. Save the file. And let's try to run one more time and see if it fixes the problem. And this time all the tests have passed and the build is success as well. Now next thing we want to do is to create documentation. Guess what I need to do? I would use the / command doc while I kept the math utilities test file open. And once we're happy with the response, we can just replace the code. So that's how we can generate test cases and documentation. And in the process, we've also seen how we can address issues in our project using Copilot. Now, obviously, since this course is not about JUnit or Java, I'm not delving deep into this logic, but I always recommend you to go through the generated code once and implement it only if it is making sense to you. Because Copilot doesn't generate accurate code all the time. You need to be able to understand the code and then make necessary changes. As an assignment, go ahead and generate test cases and documentation for your code. I'll see you next. We can give some additional context to Copilot by including files in the chat view. To include the files, we can either press the plus icon here and choose the files we want to include, or alternatively you can just choose the files we want to include and then drag them to the chat view like so. And so those would be included in the context as well. Now whatever the question you ask, Copilot doesn't just analyze the open file, it would also now analyze the included files to give you relevant answers. This might be useful in scenarios where you want Copilot to do something pertaining to the included files. Maybe you have an error that spans across multiple files and you want to give Copilot some context. Or maybe you want to include a feature that spans across multiple files. In all such scenarios, you can include those files and give Copilot some additional context. Copilot also offers context menu, which by the time of this recording is not supported in IntelliJ IDE, but is supported in Visual Studio Code. So let's go to Visual Studio Code real quick. So here I'm inside the Visual Studio Code and we basically have two files. One is math utility with couple of methods, add and subtract. And we have app class, which basically has the main method and is utilizing the math utility methods, add and subtract. I've already run the file and here is the output of the same. Now if I press hash inside the chat view, we're going to see a context menu. We can include code base, for instance, if we have any question pertaining to code base. Similarly, we have a bunch of other options as well. We can include files by choosing hash file, and we can choose the file we want to include like so. If you have any questions related to a selection in terminal, so right now we have this selected, and maybe I would like to ask, what is sum? Now since I've included terminal selection, Copilot knows that I'm asking about the sum inside the terminal and I'm not referring to a particular method in math utility. So if I press enter, it gives me relevant answer. I'll see you next. So far we have seen that Copilot is an amazing code suggestion tool, but wouldn't it be nice if it can actually edit the code for us as well? Copilot Edits is exactly that. It doesn't just generate code, it actually edits your code seamlessly. Unfortunately, by the time of this recording, that feature is not supported in IntelliJ IDE, so we're going to take a look at that in Visual Studio Code. And hopefully by the time you're watching this video, maybe that feature is available in IntelliJ IDE as well. So to utilize Copilot Edits, you see an icon next to the chat icon, that is Copilot Edits. Click on it, and by default it has included the current open file in the context. If we want, we can remove it, but let's see what it's going to do if I remove that file and ask it to edit. So right now we have these two functions, add and subtract. I want to introduce one more function called multiply. So I'm going to ask just that. It clearly didn't seem to have understood the context. It has generated multiply.javascript file with the code in it. I'm not happy with this, so I'm going to discard, and instead I'm going to provide it some context by adding files. I can either add files here or I can use the context menu to do the same. I'm going to include math utility Java file as well as app.java file, and I'm going to ask it to introduce multiply function once again. And this time it is actually generating code inside these files. So it has introduced multiply method. I'm going to accept it. And if I go to the app.java file, it is also making calls to it. I'm going to accept this as well. That's Copilot edits for you. I'll see you next. Let me now walk you through some of the best practices and strategies to optimize Copilot assistance in your Java projects. Always try to set the right context for Copilot. Copilot analyzes open files to generate relevant suggestions. If you keep related files open, it helps Copilot understand your project structure better. And always try to include relevant files in the chat view to give it some additional context. Try to manually include the dependencies by yourself. While Copilot can suggest dependencies, you should manually specify the ones you need, because you're the one who knows better about your project. For example, if you include SLF4J API dependency, Copilot will start using that library instead of any other random library. And if possible, try to include the modules you need inside the class by yourself, so that all the subsequent code generated by Copilot would use those libraries without any conflict. Always use meaningful function names or method names. Copilot relies heavily on method names to generate relevant code. If your method names are vague, the suggestions may not be accurate. So naming your methods meaningfully will help Copilot provide better suggestions. For example, instead of using the name process data, be more specific and name it as fetch products by category. With this clear function name, Copilot understands that it needs to generate a database query to fetch products by category, and it would generate the code accordingly. Try to provide some sample code for better suggestions. This is another great way to guide Copilot, which is to copy and paste small example code snippets related to your task. This will help Copilot align its suggestions with your framework and coding style. And once it generates the code, you can delete the sample code. Always be specific with Copilot. Copilot works best when you provide clear and specific prompts. Instead of vague instructions like fetch user details, be more detailed and say something like fetch user details from MySQL database and return them in JSON format using Spring Data JPA. Something like that. When you're entering prompt, try to break down large tasks. So avoid asking Copilot to generate an entire application at once. Instead, break the task into smaller manageable steps. For example, instead of saying create a Spring Boot app that manages products, integrates with MySQL, and exposes REST APIs, break it down like this in steps, like you're seeing here. First, ask Copilot to generate Spring Boot project with web and JPA dependencies, and then ask it to create an entity class for products with name, price, and category fields. And then as the last step, you can ask it to create REST API to fetch all products. So this way, Copilot will generate more structured and accurate suggestions for each step. Always analyze the generated code. Of course, Copilot speeds up the development, but never blindly copy its suggestions. Always analyze the generated code for correctness, security, and performance. Most often, Copilot doesn't generate accurate SQL queries. Sometimes it might make our code vulnerable to SQL injections. So always review, test, and refine the code before using it in production. So the effectiveness of Copilot really depends on how well you guide it. Using meaningful function names, specifying clear prompts, breaking down the tasks, and by always reviewing the generated code, we can significantly improve the quality of Copilot suggestions. So go ahead and try these techniques in your Java projects. I'll see you next. We're going to build a complete Spring Boot application step by step from scratch using Copilot. And you'd be amazed how quickly and efficiently we can build using Copilot. Even if you don't know Spring Boot, don't worry. You'll still be able to follow along and create the app with me. Now, since this session is focused on Copilot, I won't be diving deep into Spring Boot concepts, but if you're interested, you can check out my full course on Spring Boot for a solid foundation. Now let's get started. First up, we need to go to start.spring.io to create our Spring Boot project. I'm going to choose Maven here. I would leave rest of the fields to their defaults. I might choose the latest version of Spring Boot though. Our project name is demo, and I'm going to choose the Java version 21. We need to add few dependencies. We need Spring Web for REST API. We need Spring Data JPA as well for database interaction. I'm also going to add H2 database for an in-memory database, and I might also add Lombok to reduce the boilerplate code. Once we have them, click on generate. This would allow us to download the project as a zip file. We need to extract that zip file and then import the project in our IntelliJ IDE. I'm going to go to the directory and then extract it. We need to now import this project in our IntelliJ IDE. So I'm going to do just that. I'll go to IntelliJ IDE, click on menu, click on open, and then let's go to that directory. I would choose the project that we just extracted and then click OK. I'd like to open this in a new window. Now wait for a bit for the dependencies to get resolved and to download all the required plugins. IntelliJ IDE is suggesting us to install Lombok plugin. If you don't see this prompt, you can go to File menu, Settings, go to Plugins, and then search for Lombok. We need to install this plugin so that IntelliJ can process the Lombok annotations. Once you have it installed, click on Apply and OK. Wait for a bit and then we should be good to start writing our code. Let us start by creating the entity and the repository in the respective packages. I'm going to create a couple of packages. One for models and the other for repositories. Let's create the respective class files. So inside the model, we're going to have the user class, and inside the repository, we're going to have the user repository class file. It's time to use Copilot to generate the code for us. I'm going to open up Copilot chat, and guess what is the prompt I'm going to enter now. I have the user.java file open, and I would ask Copilot to generate a well-structured user entity with ID, name, email, and JPA annotations. I'll also suggest it to use Lombok to eliminate boilerplate code, and let's see what it's going to generate. It seemed to have done a decent job. We're going to replace our code with the generated one. There are a few fixes we need to make though. We can ask Copilot to fix them, but I know the issues, so I'm going to fix them on my own. I'm going to use Jakarta persistence, and I'm going to include all the modules in it. And we also need getters and setters from Lombok. This is a perfect example to say that we shouldn't blindly trust the generated code. We need to review it, understand it, and if necessary, we need to make necessary changes. So we have the model ready. Let's now ask Copilot to create repository as well. I have the user repository file open, and I'm going to ask Copilot to create a JPA repository for user entity with basic CRUD operations. And as I can see, it has done a good job. So I'm simply going to replace the code with the generated one, like so. So we have the model and the repository. The next thing we're going to do is to create the service as well as the controller. So let us go ahead and introduce service layer as well as controller. For that, I'm going to introduce a couple of more packages. One for controller and the other for service. New package, services package, which will hold services. And we're going to create one more for controllers. Let's create a class named user controller. And let's create a service named user service. Let us now generate the code for service. A service class to handle user operations with CRUD methods. So it has generated code to find, save, and delete. I also need for updation. And this has done the job for me. I'm simply going to replace the code with the generated one. There are no errors as such, and at a glance it looks good. Let us also generate the controller. I need a REST controller for user with endpoints for CRUD operations. As you can see, generated code is actually using the service. So let's use that code inside the controller. Let me take a quick look at it. It definitely looks good. Our application is pretty much ready, but there is one last step, which is to introduce database specific configurations. For that, I'm going to open the generated application.properties file inside resources directory, and I'm going to ask Copilot to do the honors. We already have this dependency, so we don't have to add it, but we can use these configurations. Save the file, and it's time to run our application. But before that, do verify everything is okay. I'm going to remove the password though. Save the file, and we should be good to go. Our code looks good. Let's run our application and see if it works as expected. Let's run our application. To run our application, let's go to demo application.java, which has a main method, and we just need to run this. For that, I can either click this play icon or press Shift F10. IntelliJ is asking us to enable annotation processing, so let's do that real quick and then run our application. Let me pause the video and revert back once our application is running. We seem to be having an error. Why not take help from Copilot to address the same? Let's copy the error trace and paste it in the chat. Let's see what it has to say. It's saying that the user is a reserved keyword in SQL. So we need to basically change the table name to something else. And it has given us the code as well. Let's go to user and change the table name like so. Save the file and let's run our application once again. Okay, this time our application is running and is started on port 8080. It's time to test our application. I'm going to use curl to test our application. For that, I have to use PowerShell, and I already have the commands handy. I'm going to share it with you so that you can also test your application. Let's try to make a GET request to take a look at list of users. Initially, there shouldn't be any users. So we got 200 OK status, and currently there are no users. Let us now try to create a user by making post request. And here is a curl command for the same. So I'm trying to add a user with the name John Doe and with the email john@example.com. The API has responded back with 200 OK, and the user is added as well. To verify the same, we can once again make a GET request, and as you can see, we can now see the user that we just added. Let us now try to send a put request, which means we want to update an existing user. And here is the command for the same. So here I'm trying to edit the user at index 1, and this is the name and the email I want to update with. Once again, we got 200 OK response, and here is the updated user. If I send GET request again, we see that John Doe is now updated with John updated. Finally, let us try to delete the user as well. And here is a command for the same. I want to delete the user at index 1. If I send get request once again, we no longer have that user. So our API is working great. One thing you need to make sure though is that you're making the right API call. Let me go back to the code. Inside the controller, in my case, the generated code has this mapping. And I'm using the same path while making the request. Do make sure that you're using the right path depending on the generated code. If you have followed along with me and if your API is working as well, then congratulations for reaching this milestone. Hope it makes sense. I'll see you next.